Title: Hydraulic vs Traction Home Elevator. Which is better for your home? Hook: when planning a home elevator project, many homeowners ask one question first: should I choose a hydraulic home elevator or a traction home elevator? Some people compare only the purchase price. But for a residential elevator, the better question is not simply which system is cheaper. The better question is which system fits your home's shaft space, travel height, pit depth, overhead clearance, energy use, maintenance access, and long-term ownership plan. Hydraulic and traction home elevators are both widely used, but they work in very different ways. Understanding these differences can help homeowners, architects, builders, and developers choose the most suitable elevator solution. Faye, what is a traction home elevator? A traction home elevator uses a traction machine, traction sheave, steel wire ropes or belts, and a counterweight system. When the traction machine rotates the sheave, friction between the ropes and the sheave moves the elevator car up or down. The counterweight balances part of the elevator load, so the motor does not need to lift the full weight of the car every time. This is one reason traction elevators are often more energy efficient, especially in homes where the elevator is used frequently. Modern residential traction elevators often use gearless traction machines and machine room-less designs. Gearless traction machines reduce mechanical loss, vibration, and noise. Machine room-less layouts can also save space because a separate machine room is often not required. That is why traction technology is increasingly common in modern home elevator and villa elevator projects. Faye, what is a hydraulic home elevator? A hydraulic home elevator works through hydraulic pressure instead of ropes and counterweights. The main components usually include a hydraulic pump, oil reservoir, control valves, cylinder, and piston. When the elevator moves upward, hydraulic fluid is pumped into the cylinder. The pressure pushes the piston upward and lifts the elevator car. When the elevator moves downward, the fluid returns to the reservoir in a controlled way. Hydraulic elevators have been used in residential buildings for many years. They can provide smooth operation and may be suitable for some low-rise homes or retrofit projects. They can also be useful in certain building conditions, where overhead clearance is limited or direct lifting force is needed. But hydraulic systems also require attention to pumps, oil valves, hydraulic components, and sometimes machine room space. These factors can affect maintenance and long-term operating cost. Faye, main differences between traction and hydraulic elevators. Traction home elevators usually have advantages in travel height, speed, energy efficiency, machine room-less design, and modernization flexibility. They are often a strong choice for multi-floor homes, frequent use, and projects where long-term efficiency matters. Hydraulic home elevators may be more practical in some low-rise residential buildings or retrofit projects, where the building conditions favor hydraulic technology. They can provide smooth operation and may work with certain shallow pit or lower overhead requirements depending on the system design. The maintenance focus is also different. A traction elevator requires attention to ropes or belts, sheaves, the traction machine, and related mechanical systems. A hydraulic elevator requires attention to the pump, oil, valves, cylinder, piston, and hydraulic components. So the choice is not only about installation, it is also about long-term ownership. Faye, gearless traction and modern residential elevators. Not all traction elevators are the same. Older systems often used geared traction machines with a gearbox between the motor and the sheave. Modern residential elevators increasingly use gearless traction machines. In a gearless system, the motor connects more directly to the traction sheave. This can improve efficiency, reduce vibration, and lower noise. Modern traction systems may also use permanent magnet motors, intelligent controllers, and compact machine room-less layouts. These improvements have made traction elevators more practical for residential applications than before. However, traction still needs proper shaft design, pit planning, overhead clearance, and maintenance access. A modern traction elevator is efficient, but it still has to fit the building. Faye, pit depth, headroom, and building compatibility. One of the most overlooked parts of choosing a home elevator is building compatibility. Many retrofit projects face limited shaft space, shallow pit conditions, low headroom, structural constraints, stairwell restrictions, or utility conflicts. Traction elevators may require more pit depth and overhead clearance than some hydraulic configurations. However, modern engineering has introduced shallow pit and low headroom traction solutions for many residential projects. Hydraulic elevators may be useful in some low-rise retrofit situations, but they may also require machine room planning and hydraulic maintenance access. This is why the building should be evaluated before selecting the drive system. A drive system should fit the house, not the other way around. Which is better for existing home retrofits? For existing homes, the answer depends on the real site conditions. If the home has limited overhead clearance, restricted pit excavation, or difficult shaft conditions, hydraulic or customized solutions may be practical. If the home can support a suitable shaft layout and the owner prioritizes energy efficiency, frequent use, quiet operation, and modernization flexibility, traction may be a better long-term option. Many successful retrofit projects are not based on standard packages. They require customized engineering around shaft dimensions, travel height, door configuration, structural conditions, and maintenance access. Which is better for elderly homeowners? For elderly users, the drive system label is only one part of the decision. Important factors include smooth ride quality, accurate leveling, reliability, emergency operation, easy-to-use controls, and wheelchair accessibility. Leveling accuracy is especially important because uneven floor transitions can increase trip risks for elderly users, wheelchair users, or people using walkers. Traction systems often perform well in leveling accuracy, quiet operation, and energy efficiency. Hydraulic systems may still be suitable if the home structure and installation conditions make them more practical. The best elevator for elderly homeowners is the system that fits the building and provides dependable daily operation. Conclusion: so hydraulic vs traction home elevator, which is better? There is no universal answer. Traction home elevators are increasingly common because of gearless machines, counterweights, energy efficiency, MRL layouts, ride quality, and modernization flexibility. Hydraulic home elevators can still be practical in certain low-rise homes, retrofit projects, or building conditions where hydraulic technology fits better. The right choice should be based on shaft dimensions, travel height, pit depth, overhead clearance, machine room requirements, energy use, maintenance access, safety needs, usage pattern, and long-term ownership cost. Before choosing a drive system, evaluate the building first. For more details, read the full article here. https://hydraulic vs traction home elevator